Hey. So today what we're going to do is we're going to start the second half of chapter 8. Um, so the first half of chapter 8, which we just completed, was all about naming polynomials, binomials, talking about degree. We talked multiplying, adding, subtracting. And then we talked a little bit about something called factoring, which is like the opposite of distribution. The second half of the chapter is all about factoring, and in particular, factoring trinomials. So we'll bring in some things that you know and some things that you maybe forgot about, but we're going to get started right away and take a look at some of this factoring, what it means to factor and how we can do that. So our topic is factoring x squared plus bx plus c. So we're going to use those letters b and c quite a bit throughout the day. EQ is how can I factor trinomials without using a GCF? Because GCF is the only thing that we learned about in the first half. So today we'll start introducing some new techniques to factor. So as a quick warm-up, we're going to multiply the binomials. If you recall, this is two sets of distribution, which you could either use the box method or you could use the or what I'm doing right now, which is just distributing. So I distributed x, this x right here, to both x and 7, and that gave me my first two terms, and now I'm going to distribute positive 2. Oops. So 2 times x should be 2x. 2 times 7 is 14. And then finally, I see that in the middle here, I can combine 7 and 2, and that makes 9. So I have x squared plus 9x plus 14. That is my simplified trinomial. And so here then, if I do the same thing, same idea, I'm going to start by distributing x through. Now, be careful that you think of that as negative 8. So x times x is x squared. X times negative 8 is minus 8x. Then I'm going to multiply by 3. So that's plus 3x and minus 24. Again, I can combine these middle terms together, and I can combine them, remember, because they both have just plain x. I can't combine like 8x with x squared because the powers are different. Negative 8 plus 3 is negative 5, so minus 5x and minus 24. Okay, so that's how we distributed or multiplied binomials in the first half of the chapter. What we're going to do today is talk about factoring. But before we do that, I want to kind of show you a little shortcut with multiplying these binomials. Okay, instead of having to distribute the whole time, a shortcut that can work from time to time is, if you notice in the parentheses, I had the number 2 and the number 7. And in my final answer, I had the number 9 and the number 14. Okay, and if you think about where these came from, if you kind of track where all this stuff came from, the 14 came from multiplying 2 times 7. And the 9 came from right here where I combined 2 and 7. Okay, so maybe a coincidence, but my final answer was really just two different ways to combine the numbers 2 and 7. If I look here, I had positive 3 and negative 8. And in my final answer, I had negative 5, which is 3 minus 8. And then I had negative 24, which is 3 times negative 8. Okay, so it looks like there's a pretty neat little pattern where I could maybe skip this step altogether and jump right to my final answer. Now, if you don't feel comfortable with it, you can absolutely just do the distribution or the box method, and I still encourage you to do it. But I do want to show you that there is a shortcut that can work. Now, the shortcut does only work as long as the x's in front are just, they don't have a coefficient or a number in front of them. But if we think about this, x times x would give me x squared. If I were to distribute, okay, if I were to distribute x times 7, that'd be 7x, and 2 times x would be 2x, then I could combine those together to give me 9x. And then finally at the end, 2 times 7, I should circle the positive. Positive 2 times positive 7 is plus 14. Okay, so that can kind of allow me to multiply them together very, very quickly. Same thing with that previous example, right? I had x squared. 3 minus 8 is minus 5x. And then 3 times negative 8 is minus 24. And that gives us kind of the quick version. So let's try it with a new problem. X minus 2 times x minus 5. Well, I know x times x is going to be x squared. That's always going to be part of this. That's always going to be the first thing that I get when I distribute. Negative 2 and negative 5 added together make negative 7. So that'd be negative 7x. And then if I multiply negative 2 and negative 5, I'll get positive 10. Now, if you were to go through and go ahead and do the distribution, you would see that these two numbers multiply to 10, but they add up to negative 7. And that is what we're going to get if you do the box method and combine like terms. Okay, so this is negative 2 plus negative 5, and this is negative 2 times negative 5. Okay, so that's kind of a nice little, I don't want to say trick, because it's not like it's not magic. It's what we're doing. It's just a quicker way to go about doing it. Okay, so that's distribution. Okay, what we're talking about in the second half of this chapter is all about factoring. And factoring is the opposite of distribution. It is, okay, I have this trinomial. How could I write it as two sets of parentheses so that when I distribute, I get this thing as the final answer? Okay. So if we think about this, I can actually use the same trick I just did. We can use the same distribution shortcut, but in reverse. Okay, first of all, if I'm going to have x squared, I know I'll have to distribute x times x. All that's left for me to do is figure out what number goes in the parentheses to accompany each x. So it's going to be x plus a number, and then x plus another number, or minus, or whatever. Okay, so if we look back at this previous example, okay, we see that this number at the end, which I'm going to call C, okay, it goes A, B, C. The number in front of x squared is A, this negative 7 is B, and then C. Okay, so if I take a look at this, I see the C value came from multiplying these together. Okay, this was multiply. My gosh. And then the B value, that minus 7, came from adding them together, adding the numbers in the parentheses. Okay, this comes from adding. So I'm about to use a phrase that I'm going to use a lot in these videos, and hopefully you use too, to kind of help you through this factoring idea. The numbers that go in here have to multiply to C, but they have to add up to B. Okay, the two numbers have to multiply to C, or 15, and add up to B, which is positive 8. So a lot of teachers have different ways of doing this. I know your intermediate algebra teacher, if it's not me, probably shows us a different way. What I like to do is I like to put the C value up top, so 15. So I need two numbers that multiply to 15. So I'm going to make a little factor tree. Okay, but when I add those factors together, I have to get 8. Now I picked a easier number combination to start with because this is the first time we're doing this. But think about what numbers multiply to 15. Okay, well, there's 3 and 5, or I could also do 1 times 15. And the question is, which of these combinations of numbers adds up to 8? Okay, so obviously 1 and 15 do not add up to 8, but sure enough, 3 and 5 do. So since I found two numbers that multiply to 15 and add to 8, that means those numbers, positive 3 and positive 5, each one of them will go into a set of parentheses with x. It doesn't matter what order. If you put +5 first and then +3, that's fine. Okay. But if you want to check your work, we're done. Okay. We've successfully factored it, because again, if I were to multiply or distribute x plus 3 times x plus 5, I would get this as a result, x squared plus 8x plus 15. So we have successfully undistributed or factored that trinomial. Okay. I know that first one was kind of a lengthy explanation, but I wanted to make it clear what we're doing, because we're going to be doing it a lot between the rest of chapter 8 and then into chapter 9. So here I have a c value of positive 24 and a b value of positive 11. Again, I have to see just plain x squared at the front. We'll talk in later videos about what happens if it's not just x squared. But I know that x squared is going to come from x multiplied with x. So I need two numbers that multiply to 24, or the c value, but they have to add up to 11. Okay. Now 24's got a lot of factors, and you may be saying in your head right away, like, oh, it's those two numbers. But let's run through some combinations. Okay. What multiplies to 24? Well, 6 times 4 is 24. But these aren't the numbers I want, because 6 plus 4 is equal to 10, not 11. So if we try again, 12 and 2. 12 plus 2 is 14, not 11. If we try again, 8 times 3 makes 24, and sure enough, 8 plus 3 is 11. So I found my two numbers, positive 8 and positive 3, so I'm going to put one in each factor, or each set of parentheses, and that's my factored version. Okay, so our answer, what we're looking for, is right here. Okay. It's a huge skill that you will use throughout the rest of math, whether it's geometry, advanced algebra. If you go to calculus, wherever you go, you will be factoring. Okay. At this point, I would like you to pause the video. Okay. Try these three problems on your own and see if you can find numbers that multiply to c and add to b. Okay. So c value here is positive 32. So I need numbers that multiply to 32, but add up to 12. Okay, again, because I have x squared, I know it's going to be x times x, and that's true for all three of these, so I'm just going to put those in right away. So if I want to find numbers that multiply to 32, okay, the first thing that jumps out to me for 32 is 2 times 16. Okay, well, 2 and 16 don't add to 12, so I want to try again. 4 will work. 4 times 8 is 32, and sure enough, 4 plus 8 is 12. So I found my numbers that go into the factors, or into the binomials. Okay, so that problem is complete now. For the next one, I want numbers that multiply to 12 but add up to 8. First thing that jumps out to me, and again, you might be saying in your head, I know what they are. First thing that jumps out to me with 12 is 2 and 6. And hey, look at that, 2 plus 6 is 8. First try, we got it. So x plus 2 is one binomial, and x plus 6 is the other binomial. Okay, and then finally down here, I need two numbers that multiply to 4, because that's my c value. Remember, it has to multiply to the c value and add up to the b value. What multiplies to 4? First thing that comes to mind for me is 2 and 2. But 2 and 2 do not add up to 5. So we try again. This happens a lot. Do not forget about the number. If you're trying to find numbers that multiply to 4, you can always use 1 and the number itself. Right? So 1 times 4 is 4, and sure enough, 1 plus 4 is equal to 5. So that's what I'm going to put into the factors with x. Okay? So factoring is, your answer should look like two sets of parentheses. It should look like a distribution problem. Okay. Well, what happens if b is negative? Okay, so we're going to look at a couple different situations here. Again, I have just x squared, so I know it's going to be x multiplied by x to give me that x squared. But now the question is, I need two numbers that multiply to 30, positive 30, but when I add them up, I have to equal negative 11. Okay, now the fact that the two numbers have to multiply to positive 30, if two numbers multiply to a positive value, it can either be a positive number times a positive, or it could also be a negative times a negative. Because anytime you multiply two negative numbers together, you'll get a positive result. So that means in this problem, I'm going to have to use a couple of negative numbers. Okay, the idea is still the same. Again, the first thing that I think of when I think of 30 is 10 and 3. But if I make them both negative, negative 10 and negative 3 is negative 13, which is not what I want. So we try again. What else multiplies to 30? 6 times 5 is 30. And if I make them both negative, negative 6 and negative 5, sure enough, those make negative 11. Okay. So I found the numbers that work for my multiplies to C and adds to B. So what I'm going to do is I'm going to put in here x minus 6. You could put plus negative 6, but it's going to be faster and easier to just put minus 6 in one set of parentheses or one factor and minus 5 in the other. Okay, so those are my factors or my sets of parentheses that will multiply to what I was given. If we try the same thing here, my C value is positive 8. So right away I'm thinking 4 and 2. At least, again, when I see 8, I'm thinking 4 and 2 right away. Now, since it's positive 8, I either need both of these numbers to be positive, but 4 plus 2 is not negative 6. Or if I make them both negative, then sure enough, this works out. So again, I've got x times x to give me the x squared in the beginning. And then minus 4 is one set of parentheses, and minus 2 is the other set. Okay. So we've successfully factored when b is negative. Go ahead, pause one more time, try these 3, and then we'll wrap this video up. All right, so I'm just going to go ahead and put the x's in here because they're all just plain x squared. Okay, so I need numbers that multiply to 1, which is kind of goofy, but adds to negative 2. Okay, well, if it's going to multiply to 1, it has to be 1 and 1. In this case, if I want to add to negative 2, I'm still okay if I make both 1's negative. So x minus 1 and x minus 1. You could then, you don't have to do this. You could write this as x minus 1 squared because it's the same set of parentheses, the exact same set of parentheses twice. And we know the second power means that you're multiplying something times itself. Okay, here, x squared minus 7x plus 6. So positive 6. I'm thinking 3 and 2 right away for 6. What multiplies to 6? But clearly that won't make 7, even if I make them both negative. And again, don't forget about the number and 1, right? So 6 and 1. In this case, I need both negative. So negative 6 times negative 1 is positive 6, and they add to negative 7. So that goes there and there. And finally, we have 32 and negative 18. So the number's getting a little bit bigger. Multiplies to 32, but adds up to negative 18. Well, I got, again, 8 and 4 is the first thing that comes to mind with 32, but that's not going to work. What else? We got 16 and 2. 16 times 2 we saw earlier was 32, and sure enough, negative 2 and negative 16 add up to negative 18. So that means in here I can just put negative 2 or x minus 2 and x minus 16, and then I have it factored. Okay, so our summary, I kind of filled it in just because I want to be very specific. Don't worry about this first statement yet. We're going to talk about that in later videos. But this is the key, is that the numbers in the binomials, okay, in the parentheses, must add to b and multiply to c. Okay. And then down here I just kind of have, if these are both positives, then these will both be plus. If the b value is negative, but I have a positive c value, then I need an x minus and x minus, meaning 2 negative numbers. That'll do it for the first video. Hopefully it wasn't too bad and it's starting to make sense because we will build on it going from here.